Howdy everybody, Steve here, KM9G. I am a ham radio guy who likes to play with Raspberry Pis, and I am in need of some screens. We showed this before in a previous video on the DigiPi setup, but now we're going to show you how to set this up as a regular screen on a Raspberry Pi. We're going to do both GUI screen, graphical interface screen, and console-based screen. And I think the console-based screen looks better and might have some more utility. I didn't find any video tutorials or any really good documentation. The install instructions that come with this do not tell you how to do this setup. So we're going to do it manually. We're going to do it on the latest version of Raspberry Pi at the time of this recording, and we're going to make it happen. I will have timestamps down below for you to do the graphical install or to do the text-based install, depending on which flavor you are interested in. So you can zoom right to that part. Before we go, if you are new here and you're coming over for Raspberry Pi stuff, I do quite a bit of Raspberry Pi stuff, and I also do quite a bit of radio stuff. So if you like playing around with technology and making things go far without wires, then this is the place for you. Be sure you are subscribed down below so you can see more stuff just like this. Let's get over to the bench and take a look at what's in the box. First, I want to get this screen here installed. So this is a 3.5-inch LCD, and it is from Waveshare, and it looks like it's a touch screen. That's going to be pretty fun to play with on a whole variety of different things. And I was hoping that it came with some standoffs and stuffs. I like how it says micro USB cable for touch and it shows you the stylus. That's not a micro USB cable. And there is no information about how to use those screws. So we'll have to wing it, whichever way makes sense to us. Pull this screen back off, and these are the small size of standoffs. And they gave me 2 standoffs and 3 screws and 3 nuts. Interesting. All right, good enough. Okay, in order to mount the screen, it seems like it is going to be fairly obvious because, well, it is fairly obvious, but the screen goes on in such a way that the GPIO pin headers line up at the top, and it follows the general Raspberry Pi shape. So it's not going to attach to every single GPIO header, and that's okay. And then those boards line up, and there's no holes in this board in order to screw it into. There's a hole way down here, but that doesn't line up with any hole in the Raspberry Pi, and then these holes here don't line up with anything. But I have GPIO pin support here, and then I have some support here for holding it down, and then we have one of those. And that's actually a pretty nice strong, that's not a little flimsy piece of whatever, that's a nice little strong screen protector, so I might put that back on and see how well that works. There is a little bit of a scratch on it already from the factory. All right, if that drives me crazy with bubbles and scratches and whatnot, I'll take it off and we'll run naked for a while. This here needs some way of being attached. Yuck, because that's going to get lost real fast. All right, let's get this thing flashed. So to get started, we're going to need Raspberry Pi Imager. We're going to go to raspberrypi.com and we're going to find it under software. And then you can download for macOS, you can download for Windows, or you can download for Ubuntu. And if you're already on a Raspberry Pi, which is a pretty cool way to do this, you would just do sudo apt install rpi-imager in a terminal window, and that'll bring it up. I'm not going to run through how to run the installer. You guys hopefully know how to do that. But there are some cool things or some tricky things about getting the image built. So let's do that. All right, so I am using a Raspberry Pi 4, but there isn't any reason why this shouldn't work with any version of Raspberry Pi hardware that can run the 64-bit OS. I'm going to choose device, and this is a Pi 4. I'm going to choose OS, and I want the latest version of Bookworm, which is 64-bit. And then before I choose storage, I need to get my SD card, put it inside of the little SD card to the big SD card adapter, and then put it inside of my computer's SD card reader. And then from there, we choose storage. I took a 32 gig SD card and I put it into my computer's SD card reader, and up pops what is very close to a 32 gig SD card as my option to burn to. So because there's a 1-for-1 match there between the 32 gig SD card and the 32 gig display on the screen here, that's the one I'm going to pick. If this thing said 256 gig or 512 gig or 1 terabyte or 8 gig or whatever, it wouldn't be the card that I just put in, so I wouldn't want to use that. So this is a good mental cue that you're on the right track here. So I picked that, and then I hit next, and it's going to ask me if I want to edit the settings, clear the settings, use the settings, or not use the settings. And so what I'm going to do is I'm going to say edit the settings. If you don't have this, it's going to ask you for settings at first. This is what makes the Raspberry Pi Imager the best tool to use for building Raspberry Pi images. So I'm going to say edit settings. I'm going to give this thing a name. The last project I worked on was the Terrestrial Amateur Radio Packet Network devices. But this one here is going to be the Waveshare screen. So I'm going to call this Waveshare for lack of any better name. And I'm going to use whatever login name I want, and and whatever password I want to go with that. And I'm going to configure my Wi-Fi right away. This is one of the magic pieces of using the Raspberry Pi Imager, is that this thing is going to be already on your network when you boot it up, and it's going to be called Waveshare.local. From there, I can set my wireless country, my time zone, my keyboard layout, all very important stuff. My services, I can enable SSH, and I can give it my public key. So that way I can log in with my SSH key and not have to worry about a username or a password. And then under options, there's some stuff here that's, it's kind of what it is. It's not that big of a deal. So I'm going to leave it set to eject. I really don't need a sound because I'm going to be sitting here watching this. And then telemetry is just telling it about how well this thing worked and how many people have downloaded and installed and so on. That's all fine. I like the Raspberry Pi people. They're good in my book. So I would like to apply these. I'm going to say yes, and then it's going to wipe out all the data on the card, and that's fine by me too. Go for it. Yes. And then it's going to ask me for an admin password so that I can overwrite a piece of media. And because I'm in the process of doing this and that's expected, it's expected. We'll be back when this is done doing its right. I mean, you might as well go take a walk while this is happening because it takes a while. All right, well, that took some time and we are back now, but you hit the continue button. Doesn't look like you should do much, but what that continue button said was take the SD card out and stick it in your Raspberry Pi. So I'm going to go do that real quick. And that's going to do its first boot up. It's going to expand the file system. It's going to take some time, and patience is what we need the most right here. When that is done, then we can get over to our console and run a whole mess of commands. I will have these commands documented for you in a link down in the description below so you can do it. And then what I'm going to do is, as I'm doing the commands, I'm going to do my best to explain what those commands do. So hopefully you'll stick around and hang out with me for a bit while we get this thing all configured. So when you first turn the machine on, that screen is going to be totally and completely blank, but that's what we're here to fix. So we got to do a whole bunch of command line stuff in order to get it fixed. If you're on macOS or if you're already on Linux, running a terminal is already built in. If you're on Windows, it's a little more difficult, not impossible. I will leave a link to Putty, P-U-T-T-Y, in the description down below, and that is a good enough SSH client to get your juices flowing and make this thing happen. In the meantime, I'm going to use macOS terminal, and since we called this thing waveshare.local and we gave it the username of pi, I'm going to type in ssh space pi at waveshare.local, and that should get us right over there. If this doesn't work, if you get like, host not found or something along those lines, then you're going to want to check your router to see what IP address was given to your Raspberry Pi. But this should work. What I'm getting here is a message that says, this host is new, you don't know who it is, would you like to trust it or not? And because I made this machine, I would like to trust it. This is one of my babies. But if you were to try to connect to a machine that you had already connected to in the past and you got this message, then you probably typed the host name wrong, or you fat-fingered the IP address or something along those lines. And this is a quick warning that, hey, maybe I might not want to send my key over the wire or type in my password here because it's not what it's supposed to be. But in this case, it's a brand new machine. You guys just were here with me building the SD card. This is its first boot up, my first login. Having it be unknown is fully expected. So I'm going to say yes, and you have to type out the whole thing, YES. So I'm going to do that, and then I'm connected, and you can see the host name and the username pi at Waveshare. So we're on the right machine. So again, we're keeping with that, matching theory of what's going on. Now I got to get some packages installed. And then I adapted these install instructions from the instructions that are here. I really had to dig hard to find these instructions because there are a couple of different versions of the Waveshare screen, and then in addition to different versions of the screen, there are also different revisions of the screen. So this is the 3.5-inch screen, Model B, revision 2.0. That was hard to find. Once I finally found that, then I got to these instructions. These instructions work with a little bit of interpretation, and then I went ahead and cleaned them up because they have a lot of things in here where they're doing like sudo unzip, for example, and you don't need to be root level privileges to unzip a file in your own personal home directory that you own. So we're going to go through the cleaned up version, but I did want to give credit back to them where the credit was due, that they did go through this trouble, and it's not bad. It does the thing. But again, back to my instructions because mine are better. So step one, we're going to have to install a bunch of dependencies that we need in order to move forward. And we need the libraspberrypi-dev for some reason in the future. We need unzip in order to unzip the files that we're downloading. We need cmake, which is probably already installed. And then I put on Joe, which is my favorite editor. If you have a favorite editor that you use that's not part of the default install, go ahead and put that in right here on this statement. Yeah, unzip was already installed, and it is installing cmake. and it's installing Joe, and it's installing that Raspberry Pi devlib. All right, and then from there, we installed unzip because we're going to need a zip file. So I have a zip file. This is actually the compiled binary driver for the screen, and we're going to go ahead and download this, and then we need to unzip it using the unzip command that we installed. And I'm going to use, even though I said they did sudo and it was wrong, I got a hot tip for you. I got a trick for you here. In this case, what I'm asking it to do is I'm asking it to unzip the file that we just downloaded in our home directory, and I'm telling it to take all of the contents of that file and stick it in this boot overlays folder. And I've already checked the zip file. There's only one file in it, and it is the boot overlay file that goes in that folder. So why do 3 steps when you can do 1 step? So let's do it. And it has inflated the DTBO file into the appropriate folder. So, less work is better in my mind. Now we need to get the frame buffer. So I'm going to download that file next. And then this one here, we don't need to be root in order to unzip this, but we do need to do some compiling work. So step 1 is unzip, and then we can cd into the rpi folder that it just created. And then from here, we need to make a build directory. I don't know why this build directory wasn't included in the zip file, but I can't fix everything. And then we need to go into the build directory, and then we need to do what's called cmake ... means go 1 level up from the folder that we are currently in right now. And as long as there aren't any big glaring errors, everything should be fine. Cmake is configuration make or something along those lines. And what it's trying to do is it's trying to make a configuration file for how the compiler should run when it builds everything. And so it needs a couple of things. The C compiler identifies as GNU 12.2.0. The CXX or C++ compiler identifies as 12.2.0. And if these were wrong versions, it would complain, and then we'd have to go fix that. But they're not wrong versions, so we don't have to fix it. And a whole bunch of other things down here that are pretty much exactly the same thing. We're just looking for dependencies on the system, and if we don't find it, it's going to report an error, and if we do find it, then we're good to go forward. So in this case, there aren't any errors, there's nothing to worry about, and then configuration done, generating done, build files have been written to. And so this is why we need to be in the build directory. These are all of your build files. So next we need to do make, and this is a 4-core processor machine, the Raspberry Pi 4. So I do make-j4, which means use all 4 cores. And this doesn't take long to build, even if you only had a 1-core machine. If you don't tell it to use all 4 cores, it won't use all 4 cores. And we're done. See how easy that was? Now there is a command we need to run with sudo coming up, and that is the install of the frame buffer. And that's because we need to write to user local bin. So there you go. We're using the install command to move that file over there. And then I am using a different editor than the standard editor. Usually the standard editor on Linux systems is Vi, which is the Elvis editor, which is very interesting. So there's a little trick here. If you specify an environment variable with your editor in it, it will use that for all of the things that do command stuff. I'm going to use that variable myself further on through this tutorial, just because it's easier than me telling you over and over again to use your favorite editor. So I'm going to set my favorite editor up, creating an environment variable, and I'm going to use the command export when I create this environment variable so that it is at every level, not just at the current shell. So if I have a subshell, it will be there. And if I had a parent shell, it might be up there above that. And if I'm running a script, it's in the script and so on. So export editor in all caps equals, and then the command of your editor, which in my case is Joe. And now I can do things like sudo $editor. So if yours was nano or pico or vi or emacs or whatever, you'd say export editor equals whatever. And then when you do this sudo editor equals line, it will pick up your editor program and not mine. We want to edit the firmware config file, and this used to be in /boot, and now with the newest version of Raspberry Pi OS, it has moved into the firmware folder. And then in here, we need to find some text that's already in here and remove it, and then we need to add some more text. So in Joe, it uses WordStar key binding, so Control-K-F, and I want to find DT overlay. And since I'm having trouble typing, I'll only type a little bit of it. I just want to comment out these 2 lines. The DT overlay VC4 KMS V3D is gone, and then the max frame buffers equals 2 is gone. Now I'm going to go to the very bottom of the file, and Joe, that's Control-KV to go to the bottom, and then I want to paste in some special text. And we'll go over what some of this stuff here is. All right, we got all that pasted in from the documentation, and there is this DT param equals SPI equals on, and that is telling the Raspberry Pi kernel to use the SPI port, which is part of the GPIO headers, which is where the screen is connected, which is where we put the screen. So like we know what we're doing here. The other ways that you can connect a display are through the ribbon cable that goes into the display header on the board, or through the HDMI ports, and you've got 2 of them on a Pi 4. From there is the DT overlay, and this is the driver that we installed in the beginning, the Waveshare 35B V2. And then all the rest of this stuff here is HDMI type stuff. So we're telling it what different types of modes and so forth that we're using, and then we're telling it that the screen size, the screen resolution is 320 by 480, which is pretty tiny compared to 1920 by 1080 or your big 4K display. So this would be the equivalent to your 1920 number, and this would be the equivalent to your 1080 number, and so on. And then the rotation is whether you want the power cable coming out of the bottom or you want the power cable coming out of the top, or if you're one of those weird people that likes to put it on its edge and run it sideways, portrait mode. We're going to go ahead and hit Control K, X, in order to save those files and exit the program. And then we need to start the frame buffer when we log in, and we need to make sure that we automatically log in. Otherwise, we won't see the desktop on the screen. So next up, I want to $editor /bash_profile. And on my install, there's nothing here yet because I haven't created this. This is your startup script when you log in. It's your profile creation. And this is where you would put things like your favorite prompt, or I don't know, have it play a sound or say a message to you when you boot in. So let's go over some of this script that I'm going to paste in here real quick. And this says, essentially, let's look at what the device tree model is. And this file here is going to return back what version of Raspberry Pi we have. And if our Raspberry Pi has the version number 5 in it, then we want to do this in a little bit of a different way. We want to use FB1 as our frame buffer, and then we want to start X Windows. Otherwise, it's a non-Pi 5, and we want to use the frame buffer FB0. We want to run the fbcp device, and then we want to start X and keep on moving forward with our graphical interface. So everything below Pi 5 is here, and everything Pi 5 is here, and then when the Pi 6 comes out, we'll have to do this all over again. But I'm sure there'll be a Waveshare 3.5J model, revision model 17 or something like that by that time. Who knows? So we go ahead and we save this. And now I need to edit another file. And this one is outside of our home directory, so we do need to be sudo for this. So sudo $editor to pull up your favorite editor that we set earlier. And then this user share x11 xorg.conf folder, and then the 99-fb turbo file. And the way this works is files in this xorg.conf.d folder are read, and they're read in numerical order. So 99 means we want this thing read last, and we need to specify what our frame buffer device is by doing this. So again, we're calling it FB Turbo, and we're telling it that the device is at FB0, and then swap buffer's weight is true. And these are all custom parameters that the folks over at Waveshare thought were important to have there. So we're going to go ahead and do that. Next up, we need to do a couple of Raspberry Pi config options. This is sudo raspi-config non-int do boot behavior b2, and this is kind of a hidden thing inside of the headers inside of the program. It's not really well documented where these things are, but this is telling you to log in and do it automatically. And that's going to take a couple of seconds. And then we're going to do another one which says do Wayland W1, which I believe is actually turning Wayland off. So next up, this screen is a touchscreen, as you saw with the stylus earlier in the video. So we're going to configure it to work with a touchscreen. And one of the benefits of this screen is that you don't need an external USB cable in order to configure your screen as if it was some kind of mouse or something. All right, so let's get that touchscreen configured. I mean, you paid for a touchscreen, so why not have a touchscreen? We've got to install a couple of prerequisites on here, the input evdev and the xinput calibrator. So we'll run the sudo apt-get install command with all of those guys on there. After we get that done, we have to copy a config file over. And I guess this is Waveshare's determination that it needs to either A, run twice, because it's going to run twice now, or B, that when it runs at level 10 and then runs again at level 45, something between 10 and 45 changes those configurations around. So it's easy enough, it's small enough to not worry about it, and it's just a bunch of configuration settings. So we'll do that one twice, but you might want to experiment with that and just do MV instead of CP. And then we need to edit a calibration config file to get it all configurated for our touchscreen here. Again, we're going to use the editor variable to pick up your favorite editor and a file called 99-calibration.conf. So they want this to run at the very bottom of the chain. It's going to be a new file, and we're going to put some contents in there that are going to define an input class for calibration of the ADS7846 touchscreen, and it's going to tell it some calibration parameters here. Swap access equals 1, enable third button equals 1, enable third button timeout 1000, etc., etc. So all of this stuff, just make sure that when you use the stylus on the screen, that where you tap is where you mean to tap, not where it thought it was supposed to be tapped from some previously bad configuration. All right, next up, I'm going to install the on-screen keyboard. And this is kind of one of those things that you might want in a pinch, but the screen is so small that when you do this, you can't really see what you're working on anyway. But it's a touch screen, and every so often you might have to really quickly type something in. So we're going to install the Matchbox keyboard, and I should put a -Y on the end of that so it doesn't ask me if I want to do it. So I'll update that in the documentation. That's included in the description down below. But now that's installed, and here's where it gets really weird. They buried the on-screen keyboard launcher down inside of the Raspberry Pi menu somewhere, and it's really hard to find. And it's hard to get to with the stylus. So I'm going to put an icon on the desktop. And since this is my desktop, I don't need to be root in order to create this file because I own the directory that the desktop is in. So we're going to call this input methods matchbox keyboard.desktop. And inside of this file, we're going to put these contents, and it's going to be a symbolic link to the application in question, which is the matchbox-keyboard.desktop file, which is buried already in your start menu. So all I'm doing is making a link from this icon to that icon. So if you update that icon, they'll both work just fine for you. And I'm telling it to use the Matchbox keyboard icon, and I'm telling it to call it on your desktop keyboard. If you wanted to change what the icon is, go for it. If you want to change what the name is, go for it. But the type equals link and the URL need to stay the same. So KX, Control KX to save and exit that. All right, I have just run the reboot command on the computer over there, and we are rebooting away. Flash on the screen lets you know it's working. Oh no, some text on the screen. It's upside down. There we go. There is the mouse pointer. There's our desktop, and there is our little icon. It's still booting up. That's letting me know about my wireless connection, which is fine. But you can see that we've got mouse pointer from the stylus. And then if I choose the start menu, yes, thank you. If I choose the start menu, somewhere in here is that keyboard thing. And see, I missed it. I don't think it's actually possible to scroll down there like you're supposed to, which is why I put it on the desktop for you. So we'll double click on that. There we go. Takes a while to load up. But see what I was saying about how it takes up a good 90% of the screen? That's going to be pretty hard to use on this screen here. So let's show you some other stuff. This screen is going to be slower than a typical HDMI screen. And because that keyboard is so very small, let's do some amazing camera work here and we'll zoom out. Because that keyboard is so very small, this is a good full-size keyboard to use, but it is still compact. It comes with a wireless dongle. This is made by Logitech. This is really good for doing regular touch typing, and then there is a touchpad over here. So now we can do some very fast typing and user input stuff instead of the stylus and touchscreen thing. So let's zoom back in here, and that's a very, very tiny screen. All right, we're at my favorite YouTube channel, and we'll pick one of my favorite videos on the channel, make it full screen. And you can see that the screen refresh, screen update rate isn't great. I mean, I can tell what's going on there, but that is not what this screen is about. But this screen would be great for developing a touchscreen kiosk interface or for having a couple of static images like a picture slideshow or something. But not very good for watching videos or playing video games or things like that. So stick to custom user interfaces or data displays. And speaking of data displays, let's get this thing reconfigured for text-only output. In order to do that, there's no reason whatsoever to have a graphical user interface installed, so we're going to start over with a fresh SD card. This is the way to get it set up if you're doing a text-only display. Things are very similar, but just a tiny bit different, and it's actually going to go a little bit quicker. And for those of you that have already seen the beginning half of this video, I'm going to go through a lot of the same stuff at the end because some people just skipped right to the end. So just enjoy. You'll be fine. We need to do the Raspberry Pi imager. And I need to choose my device, and I want to choose Raspberry Pi 4, I want to choose my OS, and I want to do Other, because it's not one of the choices up here. And then I want a 64-bit bookworm with no desktop environment, or Raspberry Pi OS Lite. And the reason why is because I don't want a desktop environment, I just want to go straight to the command line. So click that, and then choose Storage, and we've already put our 32 gig SD card into our SD card reader, and I see 32 gigs on the screen over there. So that's a 1-for-1 match. I'm not overwriting the wrong thing. We're good to go. And then I hit next. And then there are a bunch of settings in here. This is the reason why I like Raspberry Pi OS Imager more than any other way of burning an SD card image. There are, like, you can do all of this stuff without this, but you can do it with this, and this is easy, especially if you're doing a lot of things. And I've already done this 4 or 5 times today, so this is really easy for me. I can set my host name up. I can set my username up. I can set my initial login password. I can configure my Wi-Fi, and this is money right here. So my Wi-Fi SSID, my Wi-Fi password, my Wi-Fi country, and then I can set my time zone stuff, all the stuff that you do after you boot up the Raspberry Pi that you're like, why couldn't we do this in the first place? Now we can do it in the first place. For services, I want SSH enabled, and I have put in my SSH public key here so that my private key will unlock it and let me in without using a user ID or password, and then ready to go with all the rest of this stuff. This stuff's all fine. I'm going to hit save. I'm going to hit yes. I'm going to hit yes again, and then I'm going to type in my password, and then we're writing. When this is done, put the SD card in the computer, let it boot up, and we'll connect to it over SSH over the network. It's going to take a little bit of time when it first boots because it needs to expand the file system, but not that long. So we'll be back when that's ready. All right, we are booted up. So one of the things I couldn't show you in the beginning because I never had connected to the machine before, I can now show you. If you try to connect to a host that you have already connected to before, but the host has changed, like it did because we just overwrote the SD card and wiped everything out, you will get an error message like this. And it's telling you exactly what I just told you, that the remote host identification has changed because we rewrote the SD card out from underneath of everything, and that it doesn't match what we've stored in our known hosts file, and the world is coming to an end and all kinds of stuff. There is a shortcut to doing this. You can go into your known hosts file. If I edit that file directly and I come down here to the end, you can see a couple of versions of that key, the ED key, the RSA key, and the ECDSA, SH2, and IST P256 keys. You can see all 3 different versions of the key that machine presents to us to verify that it is who it says it is. I can just go ahead and delete those 3 lines, save the file, exit, and log back in, and everything's just fine. I don't want to do that. I want to show you a different trick because it is a lot faster when you're already at the command line and you already know the host name of the machine and so on. So there's this SSH keygen, which is the same command you use to generate your key. It's also the command you use to -R remove a key for a machine. In this case, the machine is Waveshare.local, which is what we named it. So SSH keygen -R Waveshare.local. And it has removed those last 3 lines for us. I don't have to edit the file. I don't have to search for them. Sometimes they're not always at the bottom because it wasn't the most recent host that I used. I don't have to save the file. I don't have to, none of that stuff. Just boom, it's gone. And now I can log in. And because that key is gone, it's now presenting a new key that I don't know anything about. And it's asking me if I want to save it. And yes, I do. Whew. And we're in. All right, we have to install some dependencies. And as we saw in the first one, I think unzip was already installed. It's okay. I've already got the script written. So we're just going to ask it to install it again. And it's just going to politely tell us that it's already done. And why did you ask me that? See? There it is. So this is installing the lib Raspberry Pi dev, so some development libraries for Raspberry Pi specifically. It's trying to install the unzip program that's already installed, and it's installing CMake, which is the configuration maker. And then I snuck in my editor on the end there. You can sneak in yours. Mine is Joe, and I like Joe. Next, we need to get the actual driver itself from the folks over at Waveshare and download it. And it comes in as a zip file, so we need to unzip it. And I am going to run sudo unzip. Normally you don't need sudo to unzip a file, and we still don't in this case, but this last parameter, this -d for destination /boot/overlays says take the contents that you're extracting from the zip file and put them over there where they belong. So it's 1 command instead of 2. It took me longer to tell you that than it would have for me to do it with 2 commands, but that's because I'm here trying to help out. Next, we need to download a zip file containing the source code for the Raspberry Pi frame buffer CP program, rpi-fbcp, and I'm guessing FB is frame buffer and CP is copy, but I could be wrong, at least on the CP part. Now that we have that file downloaded, we need to unzip it, and I don't really care where these go. I just need to work with the files, so I don't need to give it a destination or anything. Change into that folder, CD for change directory, rpi-fbcp, and then we need to make a directory for storing our build files. Then we need to CD change directory into the build folder where we just made what we just made, and then I need to run cmake ... And this ... here is telling me the parent directory is what I want to run through my configuration making tool, my CMake tool. The parent directory is rpi-fbcp, and I am in the build folder. So when I say ... I say to the operating system, give me this as the folder that we want to look for data, and then you can write all your stuff out to this folder here. So cmake ... poof. And this is looking on the system to make sure that I have the right compilers and I have all the dependencies met, and if there's an issue, it's going to give me an error, and then it's my job to go fix the error. And there aren't any errors. We found the right compiler, we found all the right libraries, everything looks good. Configuration is done, generating is done, and the build files have been written to the current folder. So now we need to make it. Make-J4, and this is the compiling step. The J tells it to use the number of cores, and the Raspberry Pi 4 has a 4-core machine. That's not the reason why it's called the Raspberry Pi 4. And because of that, I can use all 4 of them. If I don't put the J4, it's not going to use all 4 of them, and it's going to take a little bit of time. And again, this is so small that it took me longer to explain it and to use all 4 cores than it would have just to compile it on only 1 core, because it's done, as you can see. Now we need to take that file and we need to install it, and we're writing to a directory that my user doesn't have privileges to write to, so I need to use sudo superuser do, which basically says do this as root. So install the fbcp program into the user local bin fbcp destination. Now I'm going to use an environment variable, and in your case you wouldn't need to use this, but this makes it easier for me to do the rest of the tutorial without having to change things too much. Export editor equals Joe, and this says for all levels of my shell, this level and down, there's going to be an environment variable called editor with the contents of Joe. And you can put in Nano or Pico or Vi or Emacs or whatever your favorite editor happens to be. Again, mine happens to be Joe. So we're going to do sudo superuser do, and then $editor, calling that environment variable to give us the name of the editor that you chose to put into that environment variable, /boot /firmware, I can't type anymore, config.txt. And in previous versions of Raspberry Pi OS, this config.txt was in the /boot folder. Now they've changed the organization of the folder, made it a little bit cleaner, and this is where the config file exists. But this is all your kernel parameters for booting your Raspberry Pi. So inside of Joe, I'm going to do a search, Control-K-F to search for DT overlay, and there it is. So I'm going to take and comment out these 2 lines, DT overlay and max frame buffers, and I'm going to replace them down at the bottom with a whole bunch of stuff that I like better. And actually, this is the stuff that the people over at Waveshare like better, but I want to use their display, so I guess I have to like it better too. DT param equals SPI equals on says use the SPI interface for your display, and the SPI overlay, the SPI interface comes off of the GPIO pins, which is where we've plugged in our display hat. So there's a good 1-for-1 match there. I'm telling it what to do, and I'm telling it where to do it, and it's going to go ahead and do it. Then DT overlay equals Waveshare 35B, Waveshare 3.5-inch screen, Model B, version 2, -V2. And then the rest of this stuff here is for setting HDMI parameters. And the ones that are important to us are the mode and the group. And then down here, it tells us the screen resolution. This is a 320 by 480 screen, which is pretty dang tiny. Normally, you're used to using a 1920 by 1080 screen that's considered 1080p or full HD. And then a lot of the screens that are newer than that are 2K or 4K or even up to 8K screens. And you would specify the right numbers for those. But these are the right numbers for this screen. The last one here says display rotate equals 0. This is if you want the power cord coming out of the top of the Raspberry Pi, and you can change this number to have the power cord come out of the bottom or out of the left side or out of the right side if you're one of those weirdos that likes your display in portrait mode. I'm going to hit Control-K and X to save and exit, and we're going to go on to the next thing here, which is some more editing. Sudo, because I'm going to edit a file that I otherwise wouldn't have permissions to, $editor /etc/rc.local. And this is a startup script. In the previous version where we were doing the GUI, we put the startup script inside of .bash_profile, and that is the script that runs after you log in. In this case, I would like to have the screen output sooner in the boot up process, so I'm putting in an rc.local, which is the system's startup script, one of the many system startup scripts, but this is the one that we get to edit and put junk into because we don't feel like doing it the other way because we're too lazy. And then in here, I need to specify a bunch of stuff. Again, this is a lot like the bash profile, but because this isn't bash reading a bash script to run under bash, this is bash executing a file that then the operating system needs to know what to do. I need to give it this shebang line. That's what they call this, shebang, pound bang, is telling it where our script interpreter is for the rest of this script. And then this command right here says, give me the contents of this file /proc/device tree /model, and run it through this cut program to remove spaces and so on. And if all the results are removing all of that mess come back as the number 5, then this must be a Raspberry Pi 5B instead of a Raspberry Pi 4, 3, 2, 1, 0, etc. From there, it's going to set up the frame buffer parameters, and I bet that they have removed this, and they didn't mean to. So if yours doesn't work on a Raspberry Pi 5, I'm testing this on a Raspberry Pi 4, so I don't know. You might need to put that line in. I'm going to go ahead and leave it out because they left it out. And then down here, this else section is everything else that isn't a Raspberry Pi 5. And again, it has that start X. And again, we're not using X Windows, so we don't need to start X. So I can get rid of that line, which is Control Y in Joe. It gets rid of the entire line. And then we need to put an exit 0 so that this script exits successfully and goes back to the higher level and the operating system continues to boot. So we save and exit that file, and then we need to make it executable with the change mode to 755, which means root can read, write, and execute, and I can read and execute, and the group can read and execute that I happen to be in at that time. And really, it probably only needs to be 700, but this is good enough. The penultimate command is to configure the Raspberry Pi to boot up in command line mode and automatically log in as you. So do boot behavior B2. The last time I think we did B1, now we're doing B2 because we want command line and not graphical. Press enter, this command is slow, and then we can reboot the machine. Let's get over and take a look and see what that reboot looks like. All right, I have run the reboot command, and while it is rebooting, I have my keyboard ready. This is my Logitech keyboard, and it's the smallest full travel keyboard with a built-in touchpad that I have been able to find, and it runs off of wireless. The Raspberry Pi is doing its thing. You can tell by the lights there, and we saw a little flash of white there showing that the screen has come to life. And there is our text mode, and we have logged in. So I can do things like ls, or clear the screen, or run htop. And the screen feels a little bit laggy, but for the purposes of what I think I'm going to be using this for, I think it's just fine. And there you go. Let's see what it looks like with less light. It's still daytime here, and you can see the reflection of the camera in the screen and me, hi. And the screen looks great in person, but I can't get the angles lined up right to make it look so good on the camera screen. Well, there you have it. We've got a working graphical display and a working text display. And now it is up to your imagination where to go from here. Maybe it is a picture slideshow. Maybe it is some console output of something that you want to monitor at a glance on a Raspberry Pi. You never know. I am on a quest to reach 100,000 subscribers, and I am at 33,000 and change right now, almost 34,000. You could be the one that puts me over the edge. It would be really awesome if you would subscribe. There is a link right below the video. It's free. It doesn't cost you any money. It'll make you happy. Right next to that button, there is one that will cost you money, though. That's the join button. And if you feel so moved to support this channel and great content coming your way, then that is the button for you. You can do it through YouTube membership, or you can go over to Patreon if you're not that big of a YouTube membership fan. Coming up next, I'm going to try and configure this as a RTL SDR dongle based APRS decoding machine. And I'm going to show all of the decodes on the screen in real time as they come in. So be on the lookout for that. In the meantime, there's a video right over here I think you might enjoy next. Thanks for being awesome. I'll see you over there.